Hi everybody, today is June 3rd. I'm going to try to start recording videos about our homework for the remainder of Chapter 2. We already attacked the first section of problems in Chapter 2 earlier. I assigned 13 through 16 and I gave you one additional problem. So I'll try to cover those in this and probably one or two more videos because, again, I have to keep them short. Okay, so problem 13, let's go look at what we have here. Okay. The amount of money in the savings account at the end of 5 years. 5 years, okay, 5 years is what we're dealing with. And we're dealing with an initial deposit of $3,000 and an 8% annual interest rate. Stop right there, okay? We have a lot of stuff that we need to assimilate into this problem, but it all reduces down to that. All we're going to do is play with the time of compounding, okay? Now, we already know how to do the basic one here, annually. So, again, let's come back to what I always advocate here. Ask yourself two questions. Number one, is this a one-time investment or a series of payments? Okay? If it's a one-time investment, you know that we're going to be dealing with table 1 or 2. If it's a series of payments, it'll be tables 3 or 4. Okay? So we're narrowing it down here. Number 2, am I moving forward in time or backward? If it's forward in time, it's going to be table 1 or 3. If it's backward in time, it will be table 2 or 4. Always ask those questions. Now let's go back and look at our question. Friends, it says, determine the amount of money at the end of 5 years. Okay, an initial deposit of 3. All right, my two questions. Number 1, is it a one-shot deal or a series? This is a one-shot deal. We know it's going to be table 1 or 2. Secondly, are we moving forward in time or backward in time? We want to determine what's going to happen later. So this is forward in time. So we are obviously going to use table 1. The thing is, I'm giving you several interest periods here, not just annual, but then we're going to do it the same deal, semi-annual, and then quarterly. Okay? So that means we're going to have to take which table? Table 1. There it is right there. And if we do it annually, it's simple. We know that we're going to use 8% 5 years, okay? So 5 years, we know it's going to be in row 11. 8%, the factor is 1.4693, okay? So 1.4693, and we're going to multiply that by how much? We're investing $3,000, okay? All right, all you have to do is multiply it out. So I'm going to take $3,000 multiplied by the factor I gave you, and we get 4,408, and I'm just going to give us pennies there, like that. Okay, now semi-annually, what do? We go back to the table, and if we're going to compound twice a year, we can't use 8%, okay? We're going to have to use 4%. We divide the interest rate by 2, that's 4%, and we are going to have to double the number of periods because in, what did we say, 5 years? I think it was 5 years. Yes, 5 years. We know that there are 10 semi-annual periods in 5 years, so we go to that number. 1.4802, okay? 1.4802, and we multiply that by the same amount, the amount we invested. Let's have a sanity check, okay? We know that the more often we compound, the greater the number has to be. So when you plug a number in here, when you math this out, if you get a number smaller than 4407.9, you know you've done something wrong. The more often you compound, the greater the number's got to be when you move forward into the future. So 1.4802 multiplied by $3,000, the initial investment is going to give us 4440.6. So far, so good. Now, what if we compound quarterly? Okay, we know that we have to divide the annual interest rate by 4. There were 4 quarters within a year. And we know that we have to multiply the number of years times 4 because that's the total number of periods over which we'll be compounding using the master rule I gave you in my lectures. So, all right, $3,000, 8%. All right, that means 8% is going to give us, divided by 4, we'll have to use the 2% column. Okay, and in 5 years, there are how many periods? Quarterly periods. 4 times 5 means 20 of them. So we are going to use 1.4859. Again, multiplied by the original amount that we invest. Friends, it's that easy. Just say to yourself, okay, take the original table, and then do I have to do it more often than 1 year? Yes, you do. I've given you 2 examples in this case. So I'm going to take $3,000, I'm going to multiply it by 1.4859. Again, the number should be bigger because I'm compounding more often. Okay? Now, what I am going to do is I'm going to show you a proof. Okay? Now, you'll notice I've given you annual, semi-annual, and quarterly, and I've used our initial amount invested right there. Okay, so if I'm going out 5 years, okay, I'm going to use, what was my rate? 8%, okay? So I'm going to take the $3,000 I invest, and after 1 year, it will be worth, well, I'm going to do the interest. In year 1, I'll have interest of $240. Then I add that to the $3,000 I started with, so at the end of year 1, I now have $3,240. I'm going to do that for 4 more years. At the end of 5 years, I will have 4407.98, 4407.90, close enough, okay? Now, if I were to do semi-annual compounding, I would expect that my $3,000 after 10 semi-annual periods would equal $4,440 and change. Okay, now watch this very carefully. I will do the same operation, but I'm going to take $3,000 and make sure you don't multiply it by 8%. No, multiply it by 8% divided by 2 semi-annual periods in a year. That's 4%, 0.04, 120. So after 1 semi-annual period, 1 6-month period, my money has now grown to $31.20. Now when I compound that out, make sure you take it. Now I don't expect you to do the proofs, okay, but this is going to send you a message. Okay, let's make sure that number works. There it is, 4440.73. 4440.6, close enough. All right, last but not least, what happens when we compound quarterly? Okay, we're dealing with 8% annually for 5 years. Okay, so what we do is we're going to say, instead of years, we look at periods. How many quarterly periods are there? For one thing, we know that there are 4 quarters in a year. So I'm going to take my 8% rate and divide that by 4. That's going to give me 2%. I know that I'll be dealing with the 2% column. Okay? All right, secondly, I'm dealing with 5 years, 4 quarters a year. I'm dealing with 20 periods. The number I want is 1.4859. There it is, okay? Let's prove it out. So I'm going to take my $3,000, and after 1 quarter, it will have grown to 0.02. I will add $60 to it, so it will have grown to $3,060. Okay? Now, when I grow this, I'm going to have to grow that number for 20 periods. Okay? Bear with me, I'm having some cursor issues here. Okay, let's try that again. There we are. I take it down to 20 years, 20 periods, excuse me, not 20 years, 20 quarters. And I do the same thing and see what my money grows to. It grows to 445784, 445770. Again, close enough. Okay, there's my proof. All you had to do for me was this. Okay, but I wanted to give you the proofs as well. All right, I hope that makes sense to you. And now we'll move on to problem number 14. All right, now of the 4 problems, 5 problems actually, that I gave you, this one you had to be the most careful of, okay? Let's go look at it. This woman named Lisa started a paper route on January 4th, 2004. Now, this is 2 problems in one. Every 3 months, as she conducts her paper route and is paid, she's going to deposit $300 that she saves into her bank account. Right there. Stop. We're dealing with quarterly compounding, okay? It earns 8% annually, compounded quarterly. Very good. That means she'll make how much? 2% every quarter. 8% divided by 4 quarters per year. All right. Having said that, now let's ask ourselves the questions, okay? Let's go back to our questions. All right. Is it a one-time investment or a series? This time it's a series. She's doing it every quarter. So that tells you we're going to use either table 3 or table 4. Secondly, is she moving forward or backward in time? She's moving forward. So we reduce it down to table 1. For the first, table 3. Table 3. For the first half of this problem. The second half, you got to be careful. Make sure you read it, okay? Okay, so it says on December 31st, 2007. Stop right there. Okay, so you're going to do the first half of this problem from January 1 of 2004 through the end of 2007. Okay? Now, once you've got that number, we do the second half of the problem. She's going to take that entire amount in her account and she's going to put it into an investment at 12% per year. All right. She's not going to deposit any more. That makes it a one-shot deal. Okay? And she's going to invest it for 3 years, 2008, 2009, and 2010. Okay? So we're moving forward in time. That's going to be table 1 or 3. Secondly, it's a one-shot deal, no longer a series. That reduces it to table 1. Okay? So for the first half of this problem, we use table 3, but we have to do it quarterly now, right? For the second half of this problem, we will use table number 1, a one-shot deal. Okay? So because I compounded this problem, there were, no pun intended, there were 2 problems in one. Okay? So the first thing that we're going to do is we're going to say she's going to take $300 per quarter. Okay? The rate she's going to use is 8% annually. And she's going to do that for, okay, now this is where a lot of students get messed up. They say, okay, January 1, 2004, December 31, 2007, that's 3 years. No, it's not. 2004, 2005, 2006, 2007, it's 4 years. It's not 3 years. Okay, that's a common mistake. Okay, so make sure you use 4 years. Watch your dates very carefully, friends. Okay, now since we are using periodics, we're going to use table 3. Okay, let's go see what our factor is from table 3. Okay, all right, so it's 8% annually, and if she's doing this quarterly, that means we use 2%. And for 4 years, 4 times 4 is going to be 16 periods. Okay, so let's see what we get. 16 periods. Okay, it looks like we're going to be at 18.6393. All right, times the amount of the periodic payment, and that for this woman is $300. Math it out. 300 times 18.6393 is going to give us 5592.79, 5591.79. Okay, that's our first answer. Okay, now using table 1, she is going to take that number and invest it for, let's go look again, friends. She's going to invest it for 2008, 2009, 2010, 3 more years. This time she can lock in a wonderful rate of 12%, but she's no longer paying in multiple amounts. She's just letting the initial amount grow. Not table 3 anymore, table 1. She's moving into the future. So it's got to be 103. And now we know it's table 1. So we go over to table 1, and she is dealing with 12% for 3 years. Okay? There it is, 12%. 1, 2, 3 years. 1.4049. We're going to multiply that by how much she has. How much does she have? She has 5,591.79. Okay? So, when we math that out, we get 1.4049, 7,856, 855.91. Okay, now, again, that is how much she should have at the end of this entire 7-year stretch. So that's the number we're looking for. That is the answer to the question. Therefore, I'm going to give you a proof. Let's see what happens. Okay? All right, we're going to start by saying proof. There we are. And we're going to do this for how many years? All right, first of all, we're going to start with 4 years by quarter. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm doing it the hard way. Okay, then we're going to go for an additional couple of years, because after 4 years at 4 quarters a year, 16 periods, we're going to go for 1, 2, 3 more periods. Okay, so please remember, these are periods. They are not necessarily years. In the second half of the problem, they are. Okay? Very good. So let's see what we get. First of all, she is going to have interest, and I'll put that here. She is going to have a periodic investment that she makes, and she's going to have a running balance. Okay. How much does she have initially? She does not. All right. Now, at the end of the first quarter, she's not going to have any interest at all. She hasn't made any money. Okay. But now, at the end of the first quarter, she puts her first $300 in, so she has $300. Okay. I'm going to take a moment and give us pennies on all of these things. There we are. So now, at the end of the first quarter, she has 300. That's going to earn her how much? Well, 8% annually. So for 1 quarter in the second period, that amount is going to earn her, hold on please, okay, having a little trouble here. D49, okay, times 0.02. All right, that's going to earn her $6. Then at the end of the second period, she'll invest another 300, and she is going to do that how many more times? 14 more times, a total of 16 periods. Okay? So now, continuing my proof, what does she have at the end of the second quarter? She has how much she put in at the end of the first quarter, she has the interest she earned during the second quarter, and she has how much she invests at the end of the second quarter. She now has $606. Okay? I'm going to replicate that all the way for the number of periods we have, and let's see what we end up with. For the first half of this problem, 5591.79. We think it was 5591.79. There it is. It worked. Okay? Once again, I am working on a proof here. Now, my answer to the second part of the problem is 785591. That's good enough for me, but I'm going to prove it to you. So I'm going to say, okay, Lisa has 5591.79. Now, she's going to invest that money one time only for 3 more years. Okay, now we're dealing with annual periods. And she's going to invest at 12%. So she takes that 5591.79 times 12%, and in the first year, that's how much she makes. She's not making any more payments, so these numbers are going to be zero. They're going to be blank. So after 1 year, once she stops the stream of payments and begins the 12% investment, she is going to have 62.80. Okay? She is going to do that again. Again, 62.80 in the second year of this time frame will be 12%. Now she's going to have 62.80 plus another 751.54, and time is up. I'm going to do it one more time, and there's our proof. She now, at the end of the 7-year period, has 78.5606, 78.5591. It is close enough, okay? This is all I need from you for our class, but here I've given you a proof that I hope you'll find helpful, okay? I'll post this. Our time is up. I'll give you another continued video for homework for Chapter 2 and Chapter 3 later on today. Today is Saturday, June 3rd. Okay, so stand by, and I hope you're having a good day. Bye-bye.